right? Now, this limit un equal to 0. Another definition is absolute convergence. Absolute convergence. What is the definition of absolute convergence? Just let me check once again. Is it going to record or not? Yeah, recording. Now, absolute convergence definition: an alternate series sigma minus 1 whole power n minus 1 un is said to be absolute convergent, absolute convergence if first condition, if sigma minus 1 whole to the power of n minus 1 un is convergent. What is the first condition? Alternate series is convergent. And second condition, the absolute series sigma mod un is convergent. Sigma mod un is convergent. Sigma mod un means what? Positive term series. Entire series is positive term series. So condition absolute convergence means what? Alternate series is convergent, and absolute series is also, that means series of positive terms also convergent. Now conditional convergent, another one, conditionally convergent. Conditionally convergent, the definition is same. What is the series? The series sigma minus 1 whole to the power of n minus 1 un is said to be conditionally convergent, if first condition is the alternate series is convergent. Alternate series is convergent. And second one, the positive term series or absolute series is divergent. Okay, this is about absolute convergent and conditional convergent. Conditional means what? Alternate series is convergent, but the absolute series is divergent. Then it is said to be convergent, not conditionally convergent. If both are convergent, then absolute convergence. Both are convergence, then absolute convergence. Now, coming to problems. First problem. Discuss the convergence of the series. Discuss the convergence of the series let me take which problem. Yeah, 1 minus 1 by root 2 plus 1 by root 3 minus 1 by root 4 and so on. Solution. Clearly, what is sigma un here? Sigma un, one can write sigma minus 1 whole to the power of n minus 1 into, not sigma un. This is minus 1 whole power n minus 1 un is equal to 1 by root n. N is from 1 to infinity. Therefore, so what is un without signs? Un is 1 by root n. First, let me always remember, first we have to check the convergence of the alternate series, then go for the absolute series. First, let me check alternate series convergence. First one, what is the Leibniz rule? The terms must be here. Un is 1 over root n, and a un plus 1 is 1 over root n plus 1, right? So clearly 1 over root n is definitely greater than 1 over root n plus 1. It is true for all n. That means un is greater than un plus 1 for all n. This is the first condition. Now take limit. Leibniz rule. I told you Leibniz rule, first condition is this. Second condition is for un, And don't consider signs numerically less than. What is that? Each term is numerically greater than its preceding term, right? Like that. Limit n tends to infinity, un is equal to what? Limit n tends to infinity 1 over root n. So obviously, what is this value? 0. This is 2. Next. Therefore, by using 1 and 2 and the Leibniz rule, by using 1 and 2 and the Leibniz rule, the series is convergent. The series is convergent. Now coming to conditional convergent or absolute convergent. Now consider the absolute series. I'm not saying absolute convergent. Absolute series means positive series. That is sigma mod un. That means sigma 1 over root n simply. Sigma 1 over root n. This is the series. And what is the series? Clearly, this is sigma 1 by n power 1 by 2. N power 1 by 2 is of the form sigma 1 by n power p. What is p? 1 by 2, right? Is less than 1. Okay. Therefore, sigma 1 by root n is what? Divergent series as per p series test. Divergent series. Since sigma minus 1 whole power n minus 1 un is convergent and sigma mod un is divergent, the given series is conditionally convergent. Given series is conditionally convergent. Okay, this is one simple problem. Okay, now coming to another one, one can say if you consider another problem, say, yeah, take this. 1 by minus 1 whole power n minus 1 whole power n by next problem, sigma minus 1 whole power n by n factorial. Simple one, I think you can do this. N factorial. Solution. Sigma minus 1 whole to the power of n minus 1 un is equal to sigma minus 1 n equal to 0 is given here. Here summation is given from 0. N is from 0 to infinity. N equal to 0 to infinity minus 1 whole power n factorial, right? Which can be taken at, one can written as n is 1 to infinity minus 1 whole power n minus 1 by this is 0 factorial. Yeah, n minus 1 factorial. One can write like this, but no need. Anyway, what is this series? First one 1 minus 1. Yeah, this is n equal to 0 means better one can skip this. One can write n equal to 1. This term is 1. N equal to 1. This is also minus 1 by 1 factorial. 0 factorial means 1. Next one, n equal to 2 means plus 1 by 2 factorial. Next one, minus 1 by 3 factorial, and so on. And so on. This is the alternate series. Here, what is the nth term? 1 by n factorial. And what is the n plus 1th term? 1 by n plus 1 factorial. 1 by n plus 1 factorial. So clearly, nth term is greater than n plus 1th term. This is true for all n, right? 1 by n factorial definitely greater than 1 by n plus 1 factorial. When denominator increases, the value of nth term decreases. And what is the limit value? Limit un as n tends to infinity. This is limit n tends to infinity 1 by n factorial, that is 0. Therefore, both conditions are satisfied. Therefore, by Leibniz rule, the series is convergent. The series is convergent. Okay. Next one. Coming to absolute series. Now, sigma mod un is equal to sigma 1 by n factorial. Sigma 1 by n factorial. Since factorial is there, we have to apply what? Ratio test. Since factorial terms are there, we have to apply. So mod un is nothing but 1 by n factorial. Mod un plus 1 is nothing but what? 1 by n plus 1 factorial. So mod un by mod un plus 1 is equal to n plus 1 factorial by n factorial. Now apply limit for this. N mod un by mod un plus 1 is equal to limit n tends to infinity n factorial into n plus 1 by n factorial. These two gets cancelled. And what is the limit value then? Okay, I will write here itself. N plus 1 is there, so infinity. Infinity means what? Greater than 1. Therefore, by ratio test, sigma mod un is, what is this? Greater than 1 means convergent. Is convergent. Therefore, now since sigma minus 1 whole power n un is convergent and sigma mod un also convergent, the given series is absolute convergent. Absolute convergence. The given series is absolute convergent. This is one model. And one more important point here. The note is if the absolute series sigma mod un is convergent, if the series sigma mod un is convergent, then the alternate series also convergent. Then the alternate series also convergent. Alternate series also convergent. This is one more property. So obviously, what is this is absolute convergent. What is the condition? If positive term series is convergent, then alternate series is also convergent. And based on this, let us see some problems. I will write here. Examine the convergence of the series, or discuss, both are same. Examine the convergence of the series. 1 plus 1 by 2 square 1 plus 1 by 2 square minus 1 by 3 square next one, sorry, all this is printing mistake. This is 1 minus and this is plus, minus 1 by 4 square and so on. Solution. Now you can check by using Leibniz rule. Now I am avoiding Leibniz rule and directly I am considering whether series is positive term series is convergent or not. And let me clear. First thing, whenever alternate series is given, first you apply Leibniz test. Okay, if it is convergent, okay. If it is divergent, if it is not convergent, then leave it. the series is not convergent. Don't say it is divergent or oscillate. It is not convergent. That's it. And when the alternate series is convergent, then go for absolute series test. Absolute series, that is sigma mod un. Test its convergent. If it is also convergent, then both are convergent, absolute. If absolute series is divergent, if absolute series is divergent, then series is conditionally convergent. Series is conditionally convergent. Now coming to this problem, what is the nth term here? Just I'm writing nth term 1 by n square. And what is the series? Minus 1 whole power n minus 1 un equal to sigma minus 1 whole power n minus 1 by n square. I think already same problem. I think you can do this problem. This is assignment. This is assignment. Like 1 by root n problem. I will tell another one. 1 by 2 cube minus 1 by 3 cube into 1 plus 2 plus 1 by 4 cube into 1 plus 2 plus 3 minus 1 by 5 cube into 1 plus 2 plus 3 plus 4 and so on. And so on. Solution. What is the series now? Minus 1 whole power n minus 1 un is equal to minus 1 whole power n minus 1. What is nth term? What is nth term? In the first term there is 1. In the second term, okay, I am writing the numerator part. In the second term 1 plus 2. In the third term 1 plus 2 plus 3. Fourth term up to 4. So in the nth term you will get 1 plus 2 plus 3 up to plus n whole by, in the second term 2 cube, first term 2 cube, second term 3 cube, third term 4 cube. So this becomes n plus 1 whole cube. This becomes n plus 1 whole cube. Now, therefore, what is un becomes? Un is what? 1 plus 2 plus up to n by n plus 1 whole cube. This is nothing but n into n plus 1 by 2 n plus 1 whole cube. So this is n by 2 into n plus 1 whole square. N by 2 into n plus 1 whole square. Right? Okay. Now, this is un. Now check whether un is greater than un plus 1. Un is greater than un plus 1. And this is un, n by 2 of n plus 1 whole square. And un plus 1 is n plus 1 by 2 of n plus 2 whole square. 2 of n plus 2 whole square. Now I have to check whether both are, one can check by directly substituting n equal to 1, then u1, u2, compare these two, u2, u3 like that. But one general check, let me subtract. What I have to prove? Un greater than un plus 1 I have to prove. That means un minus un plus 1 is what? Greater than 0. Let me check what is this one. Un minus un plus 1, what is this value? This is equal to, anyway, 1 by 2 outside common, n by n plus 1 whole square minus n plus 1 by n plus 2 whole square. Right? Now this is equal to 1 by 2. What is LCM? N plus 1 whole square into n plus 2 whole square. Right? This is n into n plus 2 whole square minus n plus 1 whole cube. N plus 1 whole cube. So this is equal to 1 by 2. Let me expand this. This becomes n cube plus 4n. That is what? 4n plus 4n square minus n cube minus 1 and minus n square minus n whole by n plus 1 whole square, n plus 2 whole square, n plus 2 whole square. Next one. Next one, this is equal to n cube gets cancelled, right? So what is the remaining part? I'm getting 4n square minus n square, 3n square, 4n minus n plus 3n, right? And minus 1. and minus 1. Is it correct? Right. By n plus 1 whole square into n plus 2 whole square. Now this whole square means always positive terms, and this 3 of this one can write 1 by 2. 3n is common. This is n plus 1. N plus 1 minus 1. Anyway, multiplied by 3, one can write, I will write like this, 3. 3 into n square plus n by n plus 1 whole square, n plus 2 whole square. See, this is only 1 and this is multiplied by 3 into some positive value. So definitely greater than 0. Un minus un plus 1 greater than 0. So un is greater than un plus 1. This is true for all n. First condition of Leibniz rule satisfied. Now second condition, limit un n tends to infinity. N tends to infinity. What is the value of un n tends to infinity? N by 2 of n plus 1 square. So 1 by 2, I can write n common 1 plus 1 by n. N square common, 1 n gets cancelled. So choose Vn as 1 by n. That means sigma Vn equal to sigma 1 by n is divergent. Sigma 1 by n divergent. Now apply limit comparison test. Un over Vn equal to limit value n tends to infinity 1 by 2 of 1 by 1 plus 1 by n whole square. This is 1 over 2 not equal to 0 and finite. Not equal to 0 and finite. Therefore, sigma un, the series. What is the series? Therefore, this is divergent, and therefore minus 1 whole power n minus 1 un also divergent by LCD. By LCD, right? What is this one? Divergent series, isn't it? Any correct? No need of this. No, I have to take only direct limit now. No need to consider this limit comparison. All of you, are you getting? I have to apply just limit value, no, not checking divergence or like that. Leibniz rule 1, un is greater than un plus 1, and second condition is what? Just apply limit value. If limit value is 0, then convergent. Then convergent. So this is, what is this limit value? 1 by 2 of n 1 plus 1 by n whole square. Something by infinity, 0. Therefore, by Leibniz rule, sigma minus 1 whole power n minus 1 un is convergent. Is convergent. Now coming to absolute series. Now sigma mod un. Sigma mod un is nothing but sigma. What is the series? 1. What is the series? Nth term? N by 2 of n plus 1 square. Okay. Now this is mod un equal to n by 2 into n plus 1 whole square. Now you apply our limit comparison test for this. N square is common, 1n gets cancelled, numerator denominator. Now choose Vn as this. Choose Vn equal to 1 by n. So sigma Vn equal to sigma 1 by n is p value 1. What is the series? Divergent. Therefore, limit mod un over Vn, the test. Just notation only, mod un means positive term. What is this? Someone mute your audio. Un over Vn, this value is limit of 1 by 2 into 1 plus 1 by n whole square. So this is 1 by 2 not equal to 0 and finite. Not equal to 0 and finite. Therefore, by LCD, by limit comparison test, sigma mod un is what series? Since Vn is divergent, sigma mod un also divergent. Therefore, or minus 1 whole power n minus 1 un is convergent, and sigma mod un is divergent. the given alternate series is conditionally convergent. Conditionally convergent. Okay, this is one model. And next one, take this limit n equal to you say 2 to infinity. Yeah, take this logarithm problem. Already we did in limit integral test whole square. Now alternate series, that's it. Alternate series. Solution: sigma minus 1 whole power n minus 1 un is equal to sigma, and this is from 2 to infinity, right? Okay, the series. So I'm not writing this one. This is minus 1 whole power n into 1 by n log n. N is from 2 to infinity. So I will also consider 2 to infinity. Then this becomes what? Minus 1 whole power n only. Positive, negative, positive, negative. That's it. Therefore, what is un value? 1 by n log n square. N log n square. Now, what is un plus 1? Un plus 1, 1 by n plus 1 log n plus 1 whole square. Clearly, as n increases, un is greater than un plus 1. It is true for all n, right? Since denominator is increasing, un must be greater than, un is definitely greater than un plus 1. Now coming to limit value. Limit n tends to infinity. Limit n tends to infinity. 1 by n log n whole square. Anyway, something by infinity, 0. Therefore, by Leibniz rule, sigma minus 1 whole power n is convergent. Now, absolute series, sigma mod un, that is sigma 1 by n log n square. N is from 2 to infinity. Now, already we know that whenever logarithm terms are there and multiplied by n, logarithm term multiplied by n, go for integral test. So here, just I'm writing here, f of n is nothing but mod un, that is 1 by n log n square. So what is f of x? This is n. Now f of x becomes what? X log x square. This is n. N is n. When n is there, here also n. Now if I n replaced by x. Therefore, integral lim, since the n rises from 2 to infinity, here limits are 2 to infinity. F of x dx equal to 2 to infinity 1 by x log x square dx. So I can write this is 1 over x by log x whole square dx. Now log x derivative is there. Log x derivative 1 by x is there. Therefore, this is log x whole power minus 2 plus 1 by minus 2 plus 1. This entire between 2 to infinity. So this is minus 1 by log x between 2 to infinity. I think correct? Yeah, minus 1 by log x. That is equal to minus 1 by log infinity, that is 0. Log infinity, something by infinity 0, minus 1 by log 2. So 1 by log 2 finite value. 1 by log 2 finite value. Therefore, by integral test, sigma mod un is convergent. By integral test, sigma mod un is convergent. You write like this, one more step. By integral test, integral 2 to infinity f of x dx is convergent. That implies sigma mod un also convergent. Mod un also convergent. right? Since the alternate series is convergent, and absolute series also convergent, the given series is absolute convergent. Okay, this is one model problem. Okay. And remember, in alternate series test, these series are enough. Just 1 minute. Ramana sir. Unnan randi vachan. In alternate series test, just practice the problems without x terms, x power n, like that, without x terms. Okay, because syllabus is very heavy, we are omitting that topic, alternate series involving x terms. Let me check. Let me try one problem in x terms. That goes to power series. That is why we are neglecting that. In terms of x, I need no. That's also okay. No problem. And seeing assignment problems in this alternate series. First one, 1/6 minus 2/11 plus 3/16 minus 4/21 plus 5/26 and so on. Second one, 1/2 minus 1/log2 minus 1/2 minus 1/log3 plus 1/2 minus 1/log4 and so on. Third one, 1 minus 1/5 plus 1/9 minus 1/13 and so on. Fourth one, 5/2 minus 7/4 plus 9/6 minus 11/8 and so on. Another one, fifth one, sigma minus 1 whole power n minus 1 n by 2n minus 1. Take this. Sixth one, 1/1 into 2 minus 1/3 into 4 plus 1/5 into 6 and so on. These are the 6 problems assignment based on alternate series. Check any doubts or anything you want to repeat in
Sir,
alternate.
I have a doubt in previous assignment, sir.
Previous assignment. Okay, tell. Just wait.
7 questions.
Wait, shall I stop recording or shall I continue?
Continue, sir. Continue.
Okay. Which one?
7th question, sir.
I don't have that assignment sheet. Come on. What is that question?
A plus x by 1 factorial.
A plus
X by